Welcome to our Intro to Statistics, the course here, which, that is the statistics course, right, which is an introduction level. So I will touch not that many things, but everything like the basic concepts what we will see will be possibly go over. Right, the first part which we'll see is summarizing the data and get idea of summary of the data. Right, then going through a little bit of probability theorem, touch of it, and then go to the inferential statistics, right, the next part. Right, so which the first couple chapters will be about this. And the first chapter simply is introduction. What we do, and what we're going to deal with, right? The basic thing is, well, first of all, introduction. The first section is dealing with about, first thing was the data. Data basically are collections of observations like genders, measurements, survey responses or other things, right? It could be called data, like people's gender. The measurements could be weight, height of humans, or even though we care about like maybe in a county how many dogs or how many cats, right, in there, or how many trees we have there, measurements, or survey responses like when you're going to vote, like before voting, they're asking people about the idea, right? That's kind of survey responses, or some like other opinions about certain things, right? Those are survey responses. All of them are we collected in our course or in statistics are called data. And that population. Well, the word population in statistics is a little different than what we use in the daily life, right? We say population referring to amount of people when we talking generally, but in statistics, population means a little different. Right, the population, all members, defined as all members of a defined group that we are studying or collecting information on, right, for data-driven decisions. So, which we are collecting on, and the data from the population is called parameter. So it depends, still it depends. If, for example, we are interested or we are looking for the age distribution, for example, let's say in New York City, right, for the New York City, the entire population will be all people in New York City, from newborn to to all the ages, right? To all the ages. Then their age is the data is called a parameter, right? Number of people and age are parameter, but still those people in New York City is our population, right? That is the population. Or in another example, if we are interested in the age distribution, not in New York City now, but in the United States, right? If we are interested in the distribution of age in the US, right, then the population will become all the people living in the US, right, living in the US. And their age, their amount of people will be the parameter. Right? So the data of the population is called a parameter. Right? But one thing is we have some issue, right? It is maybe possible, but it takes a lot, right, to observing everyone or every single individual inside, even inside a city, right, will be very hard. Inside the New York City will be very hard, right? So the population is what we are interested in, but because of the cost, for some reason, right, was extremely too much, that we need to figure out an idea that could referring to, or best referring to that population and the data from the population, which is parameter. We need to figure out a way. And then there is a way. It's called sample. So first we have population and the parameter. Then we have a sample. Which is a part of the population, right? So referring back to the example, right, we want to get the age distribution in New York City. So what we can do is maybe observing reasonable large amount of people and see what is their age, and we can make a summary of how their age is distributed. And we are able to see the age distribution, right? So that maybe reasonable large could be 10,000 people, right, let's say, could be a reasonable large amount. Then that 10,000 people who lives in New York will be the sample from the population, which the population is every single individual in the New York City, or all of them. Right? But the sample now is the 10,000 people we observed. Right. Then the data of sample is called statistics. right? So that is where our topic or where our course is coming from, right? There is the name. So the statistics is the data of the sample, right? Which the sample is part of the population. If it is general enough, then it could be maybe a good response or a good represent to the population parameter, right? The sample statistic usually is kind of a good represent to a population parameter, and that's what we were studying and focusing on. Right, but basically, right, the population is a whole, and the parameter is taken from it, right, the collection, and sample is a part of population, and the data of sample is called statistics. Right, then the science of planning data and experiments, planning studies and experiments. Right, first of all is a plan, then obtaining data, and then to organize, to summarize, to present, to analyze, to interpretate, interpreting those data, right? So after we have plan of what we're interested in, we need to collect the data, then do something like organizing them, summarizing, presenting the data, analyzing them, and interpreting those data. And finally, we draw some decisions or conclusions. Right, so our course, Statistics, right, is a science of planning studies and experiments. The first step, right, to have something questioned or maybe something planned. Right, then obtaining the data, which most of the case are also a very hard part. And then what we were focusing on in our course will be more like organizing, summarizing, presenting, analyzing, interpreting data, and finally draw some conclusions. I believe or not, those things are kind of have rules or have patterns or have ways to do that we will touch, and the way like planning studies or obtaining data is kind of relatively harder ways, right? Harder objects. So these things we may not touch in our course here, but the following, like to organize, summarize, present, or draw conclusions, interpret, analyze, are what we're going to see later in our chapter, right, in our course. So that is what we will see in the entire semester from the first, maybe the second chapter, right? 2, 3 will be about visualizing and getting the data like in numerical way, which is find the statistics of parameter, right, such as the average or center, in other words, or variation of data, or some of the things. Right? Then also to analyze and interpreting the data drawing conclusion, maybe we'll see in the later chapter like 7, 8, or chapter 10. Which chapter 10 will be poorly in front, since that is heavily calculated, required, so we'll be putting a little bit up, and which is the chapter 10 is about linear correlation. Right? The 2 and 3 are that. Chapter 4 and 5, 6 are the introduction to probability, which is a little bit other things, right? But kind of putting together. That is what we have for our course. Well, section 1.2, you can see that we had skipped it just simply because it is talking about the conversion between decimals, percentage, and fractions, which fractions could turn into decimals by just using our calculator, and into percentage just by multiplying the decimal by 100, then attach a percentage sign afterwards. Right? So these things we could skip. Right? The section 1.3 will be our next section. Which deal with the types of data. Right? The first, well, before that, the example we'll see. Right, so in the Harris pool, 2,320 adults in the US were surveyed about body piercing, and 5% of the respondents said they had a body piercing but not on the face. Right, so that is what the first sentence is telling us, right, in the example. And right, and besides, right, based on the latest data available when the question was written, there are 241 million 472,385 adults in the United States. Right, the result from the survey, from this survey, right, the results are a sample. Are a sample drawn from the population of all adults. Right, so we need to determine what is the population parameter, what is the sample statistic, right, in our question, well, something was clear, right? There are 2,320 adults in the United States were surveyed, and about the body piercing, and 5% of them responded or said that they had a body piercing but not on the face. And the result is a sample, right, collected from the population of all adults. Right, so the last sentence also telling us that the population will be the all adults in the United States. Right, so second sentence tells us how many adults there are. The latest data, there are 241,472,385 adults in the United States. Right, that's what they tell us, and of course, we want to know about the proportion of body piercing of United States adults, but that is the case that they surveyed 2,020 adults in the US. Right, so what we get the parameter. The first is the size of the population. What we can use is the capital N usually. right? The size, which means is how many individuals we get in the population, which is type of a data, right? Here is the data in the population, so that is parameter. This capital N refers to the size of the population, which in the question clearly defined that there are 241,472,385 adults in the United States. Right, so that size is the population parameter. And statistics, first of all, we're given the size from the sample, that's 2,320 adults being surveyed. Right? And also, another thing we have given was, from those people who responded, 5% of them said they had a body piercing. So that is a thing called sample proportion. What we can use is the p-hat. Right? That capital N could be referred to, or always referred to in our course, the population size. Lowercase n refer to the sample size. And p with a hat, that's called p-hat, refer to population proportion of an object. Sorry, not population proportion. We refer to sample proportion. A population proportion is the p without hat. The p with hat is the sample proportion. So sample proportion, both with sample size, are statistics in our question here. And the population size is the parameter we get in this question. So single line underlined is from the sample. Double line here was from the population. Right, there are, for data, it could be separated as quantitative data or qualitative data, which quantitative data has a base called quantity, which referring to amount, or so other name it could be called numerical data. That is simply a number, or numbers. But as we call it numbers, we should be very careful that the numbers which is represent counts or measurements only. It has to be representing counts or measurements, right? Like amount of markers I have, right? Or the weight of my eraser, right? Or the area consuming of my board, or if you can see the volume it can take for my fridge right over here. That numbers over there are representing either the counts or measurements. Right? Those numbers are the data collected as quantitative data, or in other words, the numerical data. Another type it represents quality, called qualitative data. In other words, category categories, right, in other words, or could be called categorical data. It could be numbers still. Could be names, could be labels. That are not representing counts or measurements. Or even though it could be numbers, but those things are not representing the counts or measurements, like names or labels for some special case, right? A number behind or in front of a jersey of basketball or other baseball or some other players on the back or in front of the jersey of their jerseys, right? The numbers, right? Or or their names or their labels that can be seen, right? Those kind of thing, right? Because those kind of objects are not represent the counts or measurements. They are just identification, in other words, right? It's just the categorical data. And basically help people to distinguish who they are, what they are, or so. Right? So these things are called categorical data. So we have two types, right? Quantitative or qualitative. Right, the quantitative representing the numbers of counts and measures. Qualitative data is just of labels, in other words. But inside of quantitative data, it could be separated as discrete or the type of continuous. When qualitative data is just categorical, it cannot be, number has no other issue, right? But for discrete and continuous data, are different two types under quantitative data. Well, how we separate them is when discrete data, it can be counted individually. And the continuous data simply is not countable. But for the discrete data, like basically I will have, especially here, the number of markers I have. I have 1, 2, 3 different markers, which for qualitatively they are black, red, and blue markers, but quantitatively I have 3 markers over here. And the number of markers I have is a discrete data. I could simply count it, right? 1, 2, or 3. For continuous data is not countable, like the weight of my calculator, even though it's fixed, right, but is not countable. I cannot be actually sure like how many digits of decimal afterwards of how heavy it is. Right? It's not that accurate anyway. And also the volume of water basically could be another case. The volume of water I may drink in a random day, right? That data is also continuous data since it is not countable. Right? I cannot count like maybe I have drink 1 bottle, 2 bottles, but each bottle is a little different, right? So it is not countable in volume that exactly how much water I drink every day. So that is the most important difference. The discrete data you are able to count. It's clearly that able to count. But continuous data is not countable. Maybe fixed data you think it is countable, but like water left over in a water bottle, it is fixed, but it is still not countable. Right? That's thing considered as continuous data. Right, so for instance, to distinguish Right, well, we have 3 examples here. The amount of eggs that hens lay in a week, right, the number of rows a die required to get an outcome of 2. Right. The volume of milk a cow can produce in a year. Well, what we can see that, well, the number of eggs, maybe a hen can lay 5 eggs in a week or 7 eggs in a week, that the number of eggs will be laid in front of you, right? And you are able to count how many they are. Right, so this one simply is countable and is, in other words, is finite. Right? Also is finite, not in other words. It's countable and also it is finite. That you are able to see and has a, and the number could be stopped, basically. Right? And simply it is countable. That is discrete. Basically, it is quantitative. All of them we can see are quantitative data, which, in other words, are numerical data, right? Are numbers that represent counts or measurements. Right? The first one we are able to count, so that is discrete. And the second one, the number of rows of a die required to get an outcome too. Right? So for someone to be lucky, the first die, it maybe get 2 already, right? So the number will be 1. If someone is not very lucky, that maybe after 10 rolling of a die, it could get an outcome too, right? The die has 6 sides, 1, 2, 3, 4, 5, 6, right? Maybe after 10 rolls. Or extremely, if the die has some trouble, right, or have some issue that possibly never to get the 2 is landing, right, that could be infinitely not ends. Right? Even the number of rows is infinite for some case, right, but still that is countable. Right? So this one is also a discrete data, or maybe infinite. This one, the productivity of course has to be finite. Right, then the third one, the volume of milk a cow can produce may be between 0 to 7,000 gallons in a year, but the scale of volume itself we're not able to count, right? Even though we have machine or we have something to measure it, but still itself, right? The volume itself is a continuous scale, right? So it's not able to count, like just see how many volume, right? We usually use the word called much, right? How much volume it is. So that is continuous. Quantitative and qualitative and continuous data.